So they're an alternating power pattern of loud and soft sounds causing a pulsing sound and caused by changing constructive and destructive interference. So this constructive and destructive interference that we're hearing, okay? And it's that pulsing sound that you hear, that wah, 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 wah kind of a thing. But I know you love hearing that pulsing sound that you hear. It's caused by a change in constructive and destructive interference underneath the cart there. Yeah. It's a change in constructive and destructive interference. So because the waves are close, they overlap sometimes, but because they're not the same, they don't overlap every time. So if your wave looks something like this, and you're adding it to another wave that maybe looks like this, what you'll end up with is a wave that's really large at points and then kind of gets smaller and then gets large again. Something like that. So that's that pulsing. You hear a wah, 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 wah. See, I know you'd love hearing my voice doing that. But that's kind of the idea. The idea is they're close, but they're not the same. And so because they're not the same, sometimes they're constructive and sometimes they're destructive. Okay? And that creates kind of this different pattern between it. Okay? So how do out-of-tune instruments relate to beats? So with out-of-tune instruments, so they are slightly different frequencies. So they cause beats. So if you're wondering what's the difference between instruments that are in tune and instruments that are in tune, the only difference is out-of-tune instruments create beats, and they don't sound good, right? Like some beats are kind of interesting, but if you have this like really close frequency, and they're not quite the same, but they're almost the same, they're going to create kind of this really, really fast beat pattern, and they sound awful. And so to counteract that, we make sure the instruments are in tune. And to be honest, if you're being realistic with yourself, it only matters that you're in tune with each other. Like obviously you want it to be the correct note, but like if your notes are slightly off, but they're all slightly off, then they won't create beats and they won't sound completely awful. So that's kind of a thing like that. That's why some instruments, especially guitars, you can just tune with itself to make sure the strings are in tune with each other, and then you're good to go from there for the most part. Okay. So that's the first thing that I wanted to look at. So let's look at two examples. I'm going to do a demo for you so that you can see what these waves look like. Yeah. So again, for difference between high-pitched sounds and low-pitched sounds is frequency, and the difference between loud sounds and soft sounds is amplitude. So a high-pitched sound would look like this. And a low-pitched sound would look like this. Okay, so higher frequency versus lower frequency. And for amplitude, so loud sounds would look like this. And a quiet sound or a soft sound would look like this. Okay, so it's the amplitude that affects the volume and the frequency affects the pitch. So when you crank the volume in your car, what you're doing is making the amplitude large. Okay? When you have the volume down, then it's not very much. Loud sounds hurt your eardrums, damage your hearing, because they cause your eardrums to vibrate large. Okay? Your eardrums are not designed to vibrate that much. So when you vibrate it so much, it causes it to get damaged. Remember that shattering glass thing? That happens to your ears. If you have the pitch and it's way too loud, it can do that same thing to your ears. Okay? That's also why high-pitched frequencies hurt, because it causes your eardrums to resonate, vibrate faster. Okay? So like those really high-pitched sounds when we did the demo that you're like, oh, that's why. Because they're high frequencies, so your eardrums vibrating really fast. Okay, and that causes a little bit of mild discomfort on those. Okay, any questions on the 1970s era Soviet spy machine demo? Any questions on pitch, frequency, anything like that? Bam. Okay, go ahead and jump to notes 2 here. And let's talk about the Doppler effect.